Let's take a look at how population sizes affect voting outcomes. I have generated a script that does simulations of voting cycles where two candidates are equally as persuasive, so you can think of this as just being random assignment, where we count the overall sway or overturn, is what I call it, which would be by how many votes the one who won the election won by. Negative values will indicate one candidate has won by a specific amount, the absolute value of the negative value itself. Positive values will indicate that the other candidate has won by that specific amount. And we don't just do this once. For each population size, I will run a couple of simulations and generate a histogram of frequency. And you can see one right here. With just 10 voters, we have this histogram where somebody has actually won with all of the votes. Both of the candidates have won with all of the votes a few of the times, but the most frequent outcome is a very small overturn or sway, whatever you want to call it. And I've done this for increasing sizes of populations, as you can see. And as we go down, we might start to notice something like this. 90,000 people voting in an election. Look at this. The maximum overturn, as I called it, is 750, it would seem, for both candidates. And this led me to doing something that you might appreciate a lot. What percentage does the person who wins by, when they win by the most in each voting population, equate to in the voter population itself? So when we have very small populations, somebody might win by 100% of the population. But as that increases, you start winning, at best, by fewer and fewer percentages of people in your population. This is a sort of dilution effect. Two equally convincing candidates will end up fighting for what the law of averages, what randomness will award them. You can only expect that some statistical anomaly in your favor will happen by a specific margin. The more and more people you add, the law of averages will take over and you will be winning by less and less. If somebody is curious, you might want to look at the raw values themselves. Now, the raw value might be going up. You're winning by more votes in a bigger population, but notice like the shape of this plot. It's doing this slightly decelerating view, which is precisely why the relative version, the percentage-wise version of this, has this view, which is like 1 over x. It's falling, it's doing diminishing returns. I think you might find this quite interesting.